I want to look over a study guide for a test that would be on exponential and logarithmic equations. So I have some properties of logarithms here that are crucial to understand how logarithms work, and in particular, what a logarithm is. And so, first of all, if you have a to the y power equals x, that's the same thing as saying log base a of x equals y. So in other words, when you plug in an input into the logarithm function, what comes out is the exponent. Okay, so if you look at this study guide, the first couple of questions are just utilizing that fact. Can I change exponential equations into log equations? Can I change log equations into exponentials? And you use this windmill pattern that I'll show you. So first of all, we have write as an exponential equation, log base 5 of a equals 10. And so when I say windmill, I mean you start with your base, raised to that power, equals that. That's how I convert it to a logarithmic equation, and that's consistent with the formula we have. So writing this as an exponential equation, that means I have 5 to the 10 power equals a, and that's my answer. That's all I have to do, because all it said was write as an exponential equation. For number 2, I have an exponential equation, and it's not asking me to solve, it just says write it as a logarithmic equation. And so it's the same thing. You take your base, so you say log base 5 of 125 equals x. Okay, so that says log base 5, the input is 125, and out comes x. Okay, this is one we could actually solve for, but we're not going to. Alright, so now I want to move on to question 3. It says to solve 25 to the x power minus 125 equals 0. Classify this as an exponential equation. This is exponential. And so for exponential equations, there's two strategies. One, can I get a common base with the terms involved? And if I can't do that, I need to use logarithms. I need to take log of both sides. Okay, so in this question in particular though, I have 25 to the x equals 125. And so I can get a common base here because I can write 25 as 5 squared, and I can write 125 as 5 cubed. Okay, so I know 5 squared to the x power is 5 to the 2x power equals 5 cubed. And once I have a common base, which is the 5, I know that 5 to this 2x power equals 5 to this third power. That means then that 2x equals 3, or x equals 3 halves. And there's my answer. And if you ever doubt yourself, you can just plug it in. If I plug in 3 halves for x, that means the square root of 25 cubed, so the square root of 25 is 5, 5 cubed is 125, minus 125 is 0, so it checked. Alright, now moving on to number 4, we have a logarithmic equation. And so there's two ways to think about this. The first way to think is, remember I said that when you input into a log, what comes out is the exponent. So there's no x here, but you could write x. And so what I need to think about then is this is what power of 4 gives me 16? Okay, that's the question. Okay, so from that we can just deduce instantly that we know x has got to be 2. Now if that's not too intuitive for us, you could rewrite this as an exponential equation and say 4 to the x power equals 16, and now I can get common bases. And once I get common bases, I can drop the base and just equate the exponents, and so I get x equals 2. Either way, I get the same thing. Okay, so for number 5 here, I think in a similar way, there's no x, so I'm going to write an x here. And I think now, what power of 4 gives me 17? And that's not something I know off the top of my head. And in fact, if I try to write it as an exponential, I don't know what that is either. Okay, so I could take the log of both sides. And if I do that, I'll have log of 4x equals log 17. And it doesn't have to be log, it could be ln as well, but that's okay. And now the reason I want to do that is because one of my principles of logarithms, as you can see here, says that I have log base a of x to the n. That's the same as n times log base a of x. So in other words, the exponent can be multiplied out front. And that's what makes logarithms so useful, is because I can take this x, I can multiply it out front and end up with x log 4 equals log 17. Okay, so then I end up with x equals log 17 over log 4. And there's my answer. Okay, now you would want to plug this into your calculator like this, and when you do that, you'll get approximately 2.04. And make sure that you practice plugging that in because different calculators operate in different ways. Okay, now another way you could have solved this one is through what we call the change of base formula. And so change of base formula says that if I start with log base a of b, I can rewrite that as log of b over log of a, or ln of b over ln of a, or log base 2 of b over log base 2 of a, or any base I want. The reason we pick log and ln so commonly is because they're both in our calculators. So if that was the case, think about this then. If I started with log base 4 of 17 and I plugged it into this formula here, that would give me log of 17 over log of 4, which is exactly what we ended up with through our algebra. Okay, so the change of base formula could have circumvented all of this exponential idea, and we would have gotten the same answer. So change of base formula is very useful to know. Okay, now moving on to number 6, I see I have log base 12 of x equals 1. And so what I want to do in this case is I don't know my input, so I'm just going to rewrite as an exponential. Again, that's going to be using the windmill pattern, 12 to the first power equals x. Well, that just means then x equals 12. So really this was just an exercise of being able to rewrite this in terms of an exponential equation. Okay, now so just continuing on, I have log base 4 625 equals x. And here I don't necessarily see a common base here, but let's try rewriting as an exponential and see how that goes. I end up with 4 to the x equals 625, and I can't get a common base. So from that standpoint, I'm either going to take the ln or log of both sides. We haven't done ln yet, so why don't we do that? So I get ln 4x equals ln 625. So remember my properties of logarithms say that I can multiply the x out front and end up with x ln 4 equals ln 625, or x equals ln 625 over ln 4. Okay, now when you carefully plug that into your calculator, you should get approximately 4.64, and make sure you're getting that number. Okay, now again, remember also with the change of base formula, I could have directly said, well, okay, change of base said that's just log of 625 over log 4, or I could have done ln either way and gotten the exact same thing that we ended up with our algebra. So again, change of base formula is useful there, but you could do it either way. Okay, now moving number 8, I have log base x, so I don't know the base this time, of 256 equals 4. So since I don't know the base, I'm going to have to rewrite this as an exponential, which would mean I have x to the 4th power equals 256. Okay, so if you think now 4th powers, to undo that I need to take the 4th root, and that's going to be plus or minus the 4th root of 256. So what things raised to the 4 power give you 256? We'll see 3 to the 4th power is 81. If I do 4 to the 4th power, that's 4 times 4 is 16, times another 4 64, times another 4 is 256. Okay, so this is actually going to be then plus or minus 4. But now remember, I can't have a negative base. So then my answer then is just going to be positive 4. Okay, and so you can think this is saying 4 to the 4th power is 256. And that's correct. Okay, so for number 9, this time I have an exponential equation. So remember at the beginning we said our strategy for exponential equations is first see if we can get a common base. And I believe we can here actually, because look, this is 3 to the 3x minus 5 power. And I think I can write 81 as, let's see, well that's 9, let me think, that's 9 times 9, and each of those is 3 times 3. So that would be 3 to the 4th power. Okay, so now that I have a common base, I can drop the bases themselves and just equate the exponents. And so I end up with, let's see, 3x equals 9. And so finally, x equals 9 divided by 3, or just 3. And there's my answer. Okay, for number 10, I think we can also get a common base, because I know when I see 9, I instantly think 3's, right? So I think this is 3 squared to the x minus 1 power. And hopefully 27 is 3 to some power, and it is. It's 3 cubed, right? Because it's 9 times 3 to the negative x plus 2 power, which means then I have 3. So remember, when I raise powers by powers, that means I multiply. So that's going to be 2x minus 2. And on this side, I have 3 to the negative 3x plus 6. So from there, I just need to equate the exponents because I have a common base. And so I get 2x minus 2 equals negative 3x plus 6. Okay, so when I add, I get 5x equals, let's see, adding 2 to both sides, 8. So x equals 8 fifths. And there's my answer. I'm hoping these make sense. All right, now for number 11, is this a common base question? Well, it doesn't look like a common base at first, except I remember that, hey, wait a minute, 1 is the same as 5 to the 0 power. Okay, so this is a common base question. The trick was recognizing that 1 is 5 to 0. So that gives me 3x minus 6 equals 0, or 3x equals 6, or finally x equals 2. Okay, so you say, well, wait a minute, what if I didn't recognize that? Okay, that's fine. So why don't we take the ln of both sides instead. Alright, so I have ln 5 to the 3x minus 6 power equals ln 1. And if you remember from our properties here, ln 1 is 0. So this is going to be 3x minus 6 times ln 5. Now I can divide both sides by ln 5. Ln 5 is a real number. So I end up with 3x minus 6 equals 0. And if you notice, that's exactly where we started here. And so we'll end up with x minus 2. Okay, so even if I didn't recognize that there was a common base, and that's true for any of these, if I don't recognize common base, and I take the ln of both sides or the log of both sides, I'll still get the correct answer. And it's amazing how interconnected these are. Okay, so now we're going to look at number 12. And this is a finance question. It says Melissa wants to put $15,000 in a savings account for 10 years. And she has a choice between two accounts. One compounds annually at 3.95%, and the other one compounds continuously at 3.85%. Which should she choose, and justify your answer? So in other words, let's not just make a guess. Let's make a good guess. Okay, so we need to have an idea of what we're talking about here. And so your two financial formulas that are going on in this question. The first one, we have the future value equals your principal plus 1 plus your rate over n nt. Okay, and let me explain what some of this stuff is. A is future value. P is principal. That's how much you're investing. R is your rate. N is the number of compounds in 1 year. And T is years. Okay, so that's a lot to keep up with, but it's actually a very useful thing. Now, what about this continuously compounded account? So the continuously compounded formula means that your compounds are, how many times do you have in a year? An infinite number. Just every microsecond, every half of a microsecond is being compounded. And so what happens is your formula becomes A equals PE to the RT. All right, and these values mean the same thing. E, though, being the number that you recognize in your calculator, it's about 2.718, and this is the exponential number. Okay, so with that in mind, let's look at number 12 again. So she's going to invest $15,000. That would be how much? That would be my principal. Okay, that's what I'm starting with. And she's going to put it in for 10 years, so there's my T. All right, she has a choice between two accounts. The first one has a 3.9% interest rate, so I'll call that R1, and it compounds annually. So that means here your N equals 1, right? Because that's the number of compounds per year. The second one is continuously compounded, so I don't need an N value for that, with R2 being 3.85%. Okay, so let's calculate our future value with these two different accounts. So if I do the first one, so this is the first, I plug in 15,000 times 1 plus 0.0395 over 1 times 1 times 10. Okay, now you better carefully put this in your calculator, and you'll need to practice this, make sure you get the same thing. But if you calculate it correctly, you should get approximately $22,000, or $22,097.15. Okay, so that's the first future value. In other words, if she puts in 15,000 for 10 years at this rate, compounded annually, she'll end up with this amount, which is not too bad. All right, let's see about the second one. For the second account, it's continuously compounded, so I say 15,000 e to the rate of 0.0385 times 10. Okay, and I'm going to carefully plug that into my calculator, and when I do, I should get approximately $22,044.21, which is not bad as well. Okay, but if we're trying to pick a winner, because we want to know which one to get, we're going to go with the bigger value, right? Okay, so to summarize, I'm going to say choose the first account. Okay, and so there it is. That's it. Choose the first account because it gives us more money. Okay, so let's look at a few more of these. Alright, so number 13, we have log to the base 1/2 of 8, and we want to know what that is. Okay, so I'm going to say that that equals x. And again, I don't know what's going on here, but I'm going to rewrite this as 1/2 to the x power equals 8, using, again, my common property. You have to be able to know how to jump from exponentials to logs. That's the key idea of all this material. And from here, I'm wondering if I can get a common base, and I think I can, because I remember that 8 is 2 cubed, and I see a 2 over on the other side, and that kind of tips me off. Now, the 1/2 is not really what I want. I want 2. So remember that 1/2 is the same as 2 to the negative 1 power. Because remember, you always have that x to the negative n is the same as 1 over x to the n. Okay? So here the reciprocal just tacks on a negative exponent. So here I end up with then negative x equals 3, or maybe that's better said as x equals negative 3. And there's your answer. Okay, so now moving on to number 14, we have a logarithmic equation. Okay, so if I have a logarithmic equation and I have a constant on one side, which I do here, then what I want to do is I want to rewrite it as exponential. So it sounds like we're just repeating ourselves over and over, and basically we are. So here we say 4 squared equals 2x minus 1. That's the base to that power equals that. It's the same windmill. So then from there it's pretty easy. You get 16 equals 2x minus 1. So that's 17 equals 2x, or x would then be 17 halves. I'll write it up here just so I can get the benefit of circling it. X equals 17 halves. Alright, so number 15, if I look at this one, it's an exponential equation, but there's no way I'm going to get a common base between 5 and 7. So what do? Well, let's take the log of both sides. Okay, so I'm going to take log 5 to the 1 minus 2x power equals log 7. Alright, so now properties of logarithms say I can take out the exponent and end up with 1 minus 2x log 5 equals log 7. Alright, so from there, I'm going to divide both sides by log 5. So I have 1 minus 2x equals log 7 over log 5. So then I can say that negative 2x equals that log 7 over log 5 minus 1. And just if you think back to change of base formula, this log 7 over log 5 is another way of saying log base 5 of 7. But let's just pretend we don't know that right now. Okay, so solving for x, then I just need to divide by negative 2. So I end up with negative log 7 over 2 log 5 plus 1/2. And that is my answer. Now, if you wanted an approximate answer, so a decimal value, I'm going to carefully plug this into my calculator and end up with something pretty small, 0.10453. And there's my answer. Okay, now again, make sure you're getting that in your calculator, and if you need help, let me know. I'll try to help you. Alright, so let's look at one more. We're going to go back to a financial question. So this time Reed puts in an initial investment of $6,500 with a monthly compound at 4.36%. Okay, how long will it take for the account to accumulate to $7,000? And we're not putting any money in or taking it out, we're just leaving it alone. Alright, so remember, you have your future rate is your principal times 1 plus r over n to the nt power. And I know most of this stuff. Let's see. I know that, for example, I'm investing $6,500, so that's my P. I know I have a rate of 4.36%, so 0.0436. And I know I'm compounding monthly, so n is 12. And I don't know t, that's what I'm trying to solve for, but I do know that I want $7,000 when this is all done. So I have this equation and I'm trying to solve for t. Alright, so now in solving for t, I have to divide both sides by 6,500, so that's 7,000 over 6,500 equals 1 plus 0.0436 over 12 to the 12t power. Okay, and now what do I do? Well, this is an exponential, and there is no way I'm going to get a common base. So for that reason, I'm going to take ln or log, doesn't matter which one, of both sides. And that'll allow me then to multiply that 12t out front, right? Because remember, that's one of the reasons we use logarithms, is so that when I apply the logarithm, I can take the exponential out front. So then I should be able to solve for t by simply dividing this ln 7,000 over 6,500. I'm going to divide all that by 12 ln 1 plus 0.0436 over 12. Okay, and this is a real number, a really ugly looking real number, but it is a real number, and if you plug it in your calculator correctly, you should get about 1.72 years. Okay, 1.72 years. So you think that means, let's see, 1 year, and then how many months? Well, 0.72, that's pretty close to 75%, which would be about 3/4, which is about 9 months. So this is about 1 year and 9 months. Okay, that's about how long Reed needs to wait until he can get up to $7,000. Okay, so we've kind of gone over everything. I hope this makes sense. If you have any questions, I'd be glad to help. What you have to know, what you have to know is the fact that a to the y power equals x implies that log base a of x equals y. If you understand that, you can kind of unhinge most of these problems. If you have any questions, again, let me know, and thanks for watching.